Hi kids, we'll continue this discussion. So you can look into the first question. It says a small block is released from rest when compression in the spring is x. So you are compressing it and you are leaving it at natural. Okay, spring detaches from the block. Collision of the block with the rough surface AB. Mu value is given, E value is given. Find the minimum value of x for which the block can land on the surface CD. So what will happen when you are compressing it and leaving it? So it will increase its kinetic energy when it comes here, and it will leave the spring, and with that kinetic energy it is going to follow projectile motion. It will hit here. After that it is going to land here. So that's the idea they were talking about. So if we put that in figure, it is going to look like this. So while leaving from here, it will be coming with velocity u. So when it is going down, its horizontal velocity will remain same, but its vertical velocity will increase. Vertical velocity will be square root of 2gh. When you calculate, it will turn out to be 10. And the time taken from here to here is square root of 2h by g, which will be 1 second. 1 second. So this distance travel will be horizontal velocity into time taken. Now after hitting here, E value is half. So velocity of separation is going to be half of velocity of approach, which is 5. So why is this happening? Because of the normal. What is the impulse because of the normal? Impulse because of the normal is change in momentum along this direction, which will be 60. Change in velocity is 15 force, mass is 4. So impulse due to normal is going to be this much. Now that is integral n dt. Now impulse due to friction is integral mu n dt. Integral mu n dt is nothing but mu into integral n dt, that is mu into j. So impulse due to friction equals to change in momentum along horizontal direction. Friction is going to be in this direction, So change in momentum, when you put vector wise, you will end up getting mu minus mv, right? Impulse equals to change in momentum. Now mu value is given, j value we have understood, mass is given, we don't know u. After collision we don't know what is v, so we are putting it like that. So from here we will be getting u minus v is 15 by 2. U minus v is 15 by 2. Now apart from that, you can see here its speed is 5, and time taken to reach maximum height is u by g. U by g is half second, or you can see like this is maximum height is u square by 2g, right? This u square by 2g. So which will turn out to be 1.25. So basically you need to understand this is going to be topmost point of the next projectile. Topmost point of the next projectile, which will take only half second. In half second, what is the distance travel along horizontal? That is v into half. So this total distance is u into 1 plus v into half, which is 45 by 4. U into 1 plus v into half is 45 by 4. So there are two equations, two unknowns, we need to solve for them. When you solve for u and v, you will get u is 10, v is 5 by 2. Now u is 10. Basically whatever potential energy of the spring was there, it is converting into kinetic energy when it is coming here. Potential energy is converting into kinetic energy. From there you can substitute the values and you will be getting what was the compression in the spring initially, right? A uniform stick with mass m and length L is initially at rest on y-axis, along the y-axis on a frictionless table as shown in the figure. An identical stick to oriented in x direction is traveling with speed v in the x direction sticks to one end of the first stick, forming a right angle triangle of the object. The heat lost in the collision. See, now I am going with the idea like heat lost is going to be same in any frame. So I am going to work in center of mass frame. This idea you can see from like there was some video, you can watch the video, perfectly inelastic collision thing. So this idea was already discussed there. I am observing from center of mass frame. When I observe from center of mass frame, it is going to look like this. Velocity of center of mass is going to be v by 2 in this direction. When I observe from a frame which is moving with v by 2, I will be feeling this guy's velocity is v by 2 and this guy's velocity is v by 2. Now I know in center of mass frame, momentum of the system will be 0, center of mass won't be moving. Now this is just before collision. Now just after collision, velocity center of mass won't be moving. Center of mass won't be moving, but it will be rotating about the center of mass, because about center of mass angular momentum is not 0. About any point, in fact, you can watch the video. There are many good things you can learn from this particular thing, right? Yeah, you can observe from the video. So net momentum is 0, so center of mass after collision won't be moving. Center of mass will be here, because center of mass of this rod will be here, this rod will be here, net center of mass will be somewhere here. So it will be rotating about the center of mass. Center of mass won't be moving, so you can call that as instantaneous axis, right? Now I can do conservation of angular momentum because all the forces are internal forces. Again, I can do conservation of angular momentum about any point. No matter about which point you are going to do, the equation is going to look same in this particular question. Now let me calculate moment of inertia about this axis first. If I want to calculate moment of inertia about this axis, then I need to use parallel axis for the rod, ml square by 12 plus m into this length square. For this guy also it's the same. So this is the moment of inertia of the entire system. right? So what is the initial angular momentum? This is L by 4 into mv by 2, L by 4 into mv by 2, both are adding up in the same direction. This is the initial angular momentum. Final angular momentum is I omega. I have rewritten the same equation. Now I didn't solve for omega, you could have solved for omega also. Once you know omega, you know what's the final kinetic energy, half I omega square. You can calculate initial kinetic energy, final kinetic energy, and you can see what is the difference. Now I am doing the same thing, but I am going in a slightly weird way, I mean at least for me. So I am going with L square by 2I. Half I omega square I can write it as L square by 2I, like kinetic energy is P square by 2m. Similarly, here kinetic energy is L square by 2I I can write. L square by 2 times of moment of inertia. So this is the old kinetic energy. New kinetic energy. Old kinetic energy is how much? Half mv by 2 square, half mv by 2 square. This is the old kinetic energy, and this is the new kinetic energy. This is the loss which will be going as heat, and heat loss will be same in any frame, right? And yes, so this was the question from, it will be there in the doubt section, conservation of angular momentum in inelastic collision, perfectly inelastic collision. You are standing on a bridge watching the boats in the river. You see motorboat passes directly below you, traveling perpendicular to the bridge at a speed of 3 meters per second. A person on the boat throws a ball at initial speed of v0 at an angle 37. Both v0 and 37 angle are with respect to the boat. So now with respect to the boat, he is throwing something at a velocity v0 and 37 from the vertical. So when you resolve it, v cos 37, v sin 37, you will be getting. Now this is velocity with respect to boat. Now with respect to ground, it is velocity of the boat and velocity with respect to boat. Velocity of the boat and velocity with respect to boat. Now with respect to ground, this should travel in the vertically upward direction. The meaning is net horizontal component for the ball should be 0. So these two should be getting cancelled. 3 v0 by 5 equals to 3. From there you will be getting v0 is 5. That's a straightforward question, right? An world record player of 10 centimeter radius turns at 10 radians per second while mounted at an angle 30 inclined. A particle of mass m can be placed anywhere on the rotating record if the least possible coefficient of friction is mu. That must exist for no slipping. So we need to see where the friction needed is maximum, and we should be able to support that particular point. When you understand that, then if you take any particular radius r, you will understand that the bottommost point is going to be like needing more friction, because at this particular point, friction minus mg sin theta equals to m omega square r, that is friction equals to mg sin theta plus m omega square r. So at the bottommost point it will be more. If I take any radius r, then friction needed should be this much, so mu into n should be greater than or equals to that needed friction value. And normal in this particular case, anywhere it will be mg cos theta, so mu value should be greater than tan theta plus omega square r by g cos theta. Now this is for any r. So and you can see mu is proportional to r. So when you increase r, the more the radius, the more mu value it's needed. So it's needed for the outer region. It's not for any small radius. It's like for the bigger radius and at the bottommost point. So yes, from there, Kepler, when you substitute, tan theta is given, omega square is given, radius is given, g value, cos theta value. When you substitute, you will be getting this thing, and 2 root 3 mu you can calculate, right? A mass 1 kg which is free to move on a horizontal frictionless surface is attached to one end of the massless string that wraps partially around a frictionless vertical pole. Okay, we are seeing the top view. You hold on to the other end of the string at t equals to 0. Mass of the speed is v0. Mass has speed v0 in the tangential direction along the dotted line of the circle. Your task is to pull the string so that the mass keeps moving along the circular path of radius r. If at any instant t, force applied by the hand on the string. See, basically there is some ambiguity in the question, like they said initial speed is v0, but later moment they never said what is the speed, so they were like taking any at the initial situation itself. If at instant t, maybe you can take initial situation itself, at instant t equals to 0, force applied by the hand is 2 Newton, then find out the centripetal acceleration. Now, who will provide centripetal acceleration here? Tension will be in this direction, so tension's component will provide centripetal acceleration. Tension's component, whatever force you are applying, that will be same as tension. So F cos theta. F cos theta will be acting as centripetal acceleration, that is mv square by r. This is centripetal acceleration, mass is given, this force is given as 2. Force is given as 2. So from here we can see centripetal acceleration is 2 cos theta. Now cos theta from the figure we need to find when you draw this figure. Cos theta is small r by capital R, sin theta is small r by capital R, which is root 3 by 2 given in the question. So theta is 60 degrees. So cos theta is going to be half. From here we will be getting centripetal acceleration is 1. A rocket is projected straight upward and explodes into 3 equally massive fragments just as it reaches the top of its flight. See, at the top of its flight, velocity is going to be 0, so momentum is going to be 0. Now, explosion is going to happen for a small amount of time, so gravity is not going to change the momentum of the system significantly because gravity is non-impulsive, or the other way of saying it is, finite forces acting for a small amount of time is not going to change the momentum of the system significantly. You can get it from integral f dt equals to change in momentum. So momentum just before explosion and just after explosion is going to be 0. One of the fragments is observed to come straight down in 2 seconds, while the other 2 takes 4 seconds to come to the ground after the burst. Find the height. Now you can see they have given these 2 angles are same. These 2 angles are same. So yeah, by momentum conservation I can say, okay, if I resolve it, okay, let me say this guy has some x component, some x component, some y component, some y component. I can easily show you these 2 x components should be same because momentum of the system along the x axis should be 0. So these 2 masses are same, so velocities also should be same. So if these 2 components are same, okay, so v2 cos theta equals to v3 cos theta. So v2 cos theta equals to v3 cos theta. So from there I can conclude v2 equals to v3. So v2 sin theta equals to v3 sin theta. v2 sin theta equals to v3 sin theta, which I am calling it as y and y. So this one also will be y. Now by momentum conservation along y axis I can get this velocity has to be 2y. That's all. Now what is the time taken by this guy? Let me say this height is h. So it is in the downward direction. S equals to ut plus half at square if I apply for this guy, minus h equals to, okay, I think I used for this guy. So for this guy, it is going like this and coming like this. So what is the displacement? Minus h. Displacement equals to ut minus half gt square, ut plus half at square with signs correspondingly. Now similarly for this guy, s equals to ut plus half at square with corresponding signs. Now we need to find the value of h. You can see here the calculation is going to be easy. These 2 are going to get cancelled. So I simply added up and I will be getting the answer. So this is the equation for this guy and this is the equation for this guy. A capstan is rotating a drum over which rope or cord slides in order to increase the tension due to friction. If the difference in the tension between the 2 ends of the rope is 500 Newton and the capstan has a diameter of something and rotates with angular velocity, capstan is made of iron and has mass specific heat. At what rate does the temperature rise? Assume that the temperature of capstan is uniform and all the thermal energy generated flows into it. Express your answer. So basically what is happening? This tension is less than this tension. So if I take the drum and that string as my system, then there is torque. Torque is trying to rotate it this way. When the torque is trying to rotate it this way, angular velocity has to increase. But angular velocity is remaining constant. The meaning is like I am trying to apply some torque in the opposite direction, which is exactly equal in magnitude to this torque. So what is that torque? R into T naught minus R into T. R into T naught minus R into T. Perpendicular distance into force, right? Torque. This is the torque applied by the tension thing. Magnitude wise, I have taken R common and difference in the tensions is given in the question. So magnitude wise the torque is 25. So whatever torque I am applying is also 25. So what is the work done? What is the rate at which I am doing work? It's like equivalent to F dot V, right? Torque d theta is work done. So torque into omega is going to give me power, right? So power is 250. I am spending this much joules in 1 second. Where is it going? It is not going as change in kinetic energy, it is going as heat. So whatever energy I am spending per unit time, that is going as continuously to increase the temperature. Q equals to ms into dt, dq equals to ms dt, dq by dt equals to ms dt by dt, right? So from here you can see what is the rate at which temperature is changing. Those values were given. You can just substitute m in s and you can get the answer, right? A uniform solid sphere rolls down a vertical rigid surface without slipping. The vertical surface moves with the acceleration g by 2 in horizontal direction. The minimum coefficient of friction between the sphere and the vertical surface to prevent slipping. See, whenever 2 things are moving, it's always better to sit on one and observe the other, or sometimes it will be easy to observe from center of mass frame. So we'll be sitting on the rod. When we sit on the rod, okay, before sitting on the rod, what are the real forces? Weight, normal and friction. So when I sit on the rod, there will be extra pseudo force, that is mass of this guy into acceleration of this guy in the opposite direction. This is pseudo force. Now with respect to the rod, he is not going to move in this direction, so N equals to mg by 2. Now apart from that, we will be going with the regular algorithm. This guy is going to go in this direction with respect to the rod, so mg minus f equals to mass into acceleration in this direction. Now apart from that, when I take torque about center of mass, there is a good thing about taking torque about center of mass. Torque due to pseudo force is going to be 0. When I take torque about this point, torque due to this force is going to be 0. Okay, so torque due to friction, R into F equals to I alpha. Now no slipping condition, that is this point should be having same acceleration as the rod, which is 0 with respect to this frame, right? So A minus R alpha equals to 0 or A equals to R alpha. This is F equals to ma, this torque equals to I alpha, this is the constraint relation. From there we need to solve for friction. So I am going to write this equation as it is. R and R I am cutting, R alpha I am calling it as A. So from here I am finding ma is 5 by 2f and I am substituting it back. From there I will be getting friction. Now friction, if I know, then maximum value of the friction should be greater than this. Maximum value of the friction is mu into m, that should be greater than 2 by 7 mg. N value is mg by 2. When you substitute, you will be getting the required answer, right? And yes, this question, if a gravitational force between 2 point masses of mass, yeah, you can read this question. It's like it's a conversion of electrostatics question. I will be discussing the electrostatics question. This you can do by yourself by using this analogy. So Gauss law is going to be valid when the force is of inverse square in nature. So field is of inverse square in nature in both electrostatics as well as gravitation. So if the Gauss law is valid here, it is valid here also. So basically K into Q is equivalent to G into M. K is 1 by 4 pi epsilon naught. Now Q by epsilon naught is equivalent to 4 pi Gm. So Gauss law you can use in gravitation, but instead of Q by epsilon naught as the flux, you can use it as 4 pi Gm as the flux, where M is the mass enclosed, right? So that question you can do by yourself. I will be discussing this question. An insulating hollow cube of side L carries uniform charge on it, all of its surfaces. The surface charge density sigma determine the force acting on a face due to the other surfaces. It's the same question here if you see. Hollow cube of mass m, force due to the remaining 5 faces, force on one side, force on one face due to the remaining 5, it's the same thing. Force on a face due to all the other faces. See, this kind of thing we have already discussed in the revision class. So when it is symmetrical situation and when you know the flux, then you can write the force is going to be charge density times of flux. So this idea was already taken in revision class. So now what we need to do, we need to find the flux because of the remaining 5 surfaces. Now if you take Gaussian surface in the symmetrical like cube manner, then the total flux through the Gaussian surface of the cube is going to be charge enclosed by epsilon naught. Charge enclosed is total charge enclosed, that is 6 times of sigma a by epsilon naught. For each plate it is sigma a, so total 6 plates are there, so total charge enclosed is this much by epsilon naught. Now what is this? This is the flux through any one dotted area. Let me talk about this area. So through this dotted area, the flux is this much. What is that? That is the total flux because of the 6 faces. Now if I take just one face, now yeah, so total flux through one envelope, total flux through this 6 faces is q by epsilon naught, but through this face alone is going to be 1 by 6th of that. Now what is this? This is the total flux through this dotted Gaussian surface. This is the flux through only one face of the Gaussian surface. Now you need to understand this flux is because of 2 reasons. That flux is because of the remaining 5 sides and this side. But what we need flux because of only remaining 5 sides. This is the flux because of 5 sides plus this one side. So if you can find flux because of this one side, this one face, then if you subtract, then you will get the flux because of the remaining 5 faces. Now flux due to one surface, flux due to this one surface, because it is in the surroundings. When it is in the surroundings, you can easily calculate flux is going to be half flux will go this way, half flux will go this way, right? Now this is the thing. So half flux will go this way, half flux will go this way. So what is the charge enclosed? Charge enclosed is sigma into A. Sigma into A. So half flux will go, half flux due to this phase will go this way. Half flux due to this phase. So half flux due to that phase is going to go this way. Half flux will be going this way. So anyway, don't bother about that thing. What is the total flux because of the 6 phases? Total flux is this much. Sorry, total flux because of 6 phases is this much. Due to 6 phases for the entire Gaussian surface. For the entire Gaussian surface, it is this much. So from now onwards, I won't be bothered about that. Now I am concentrating on this one phase. So total flux because of all 6 phases or due to the entire cube. Total flux because of the entire cube on this Gaussian phase is sigma A by epsilon naught. Now flux because of only this side of the cube on this Gaussian surface is going to be this much. So what is the flux because of the remaining 5 phases? It is going to be the subtraction of these two, right? Subtraction of those two. So when you substitute that difference, sigma A by 2 epsilon naught, you will be getting the answer, right? Next question goes like, a cubical wire frame is constructed using 12 identical uniform rods of length L and linear mass density. Then 9 of these are removed and the rest 3 are such that they are mutually skew and perpendicular to each other. The gravitational field intensity at the center of the cube. Again, this also was a derived question from here probably. So I will be solving this question from electrostatics. 3 identical thin uniformly charged filaments are fixed along 3 sides of the cube. Length of each filament is L and the cube is geometrical construct and not made of any matter. Okay. So that's the question, and yes, so this colors, corresponding colors, you can see field due to this one at the center and field due to this one at the center, field due to this one at the center. Like when you write in vector form, like magnitude wise, you know it will be constant because it's symmetrical situation, right? So magnitude wise it is constant, direction wise only it's different. When you write in vector form, you will be getting electric field due to first guy. Oh, okay. Then I mentioned the numbers: first guy, second guy, third guy. So electric field due to those 3 people will be in this particular format. When you add them, it is going to be 0, right? So maybe I had my solution here. So it's like, yeah, I have used this thing. Field due to line and circular arc are going to be of similar nature, which I have discussed in revision class. So it is going to be bisecting. Field is going to be bisecting. Anyway, by symmetry you can say here like field will be bisecting. So field due to this thing should be in this particular direction. Field due to this rod will be in this particular direction. Field due to this rod will be in this particular direction. Now those directions I have mentioned, you can cross check by yourself, and magnitude wise it is going to be same. So magnitude into this direction thing. Magnitude into this direction thing, magnitude into this direction thing. When I add them, it is going to be 0, right? A giant uniform solid hemisphere of mass m and particle m are in gravity free space. Particle is initially located at a distance r in the plane containing circular base. When it is released, it moves at an angle 0.1 radian with the line joining the center and the initial position of the okay. So its initial acceleration is found to be 1 unit in particular system of units. Find the value of gm by r square in the system of units. 3 decimal places. See, the idea is when you place one more solid hemisphere, one more solid hemisphere, net field has to be towards the center. So basically due to solid hemisphere, the field, I am going to convince you like the field will be in this, they said it is in this direction, which is in this plane itself, So I am going to resolve it into x component and y component. Now I am going to convince you there won't be field perpendicular to this, because by symmetry, if there is field perpendicular to this, in the next point also field should be in this direction, So when you rotate this figure slowly, you will see like electric field line has to form a closed loop. By symmetry, you can conclude that this field won't be existing. Now for a solid hemisphere, there is some kind of symmetry missing, so this component is coming into picture. When you place full hemisphere, then by symmetry this component is going to be again nullified, right? So this is due to one hemisphere. Now if I put one more hemisphere up, then the field is going to be x and y. So this one only, right? So when I put one more hemisphere up, then the field will be y and x. Now due to full sphere in the sense, the summation of these two, y and y will get cancelled, you will be getting x and x. So net field due to full hemisphere is 2x. Net field due to full hemisphere will be g into mass by r square. But what is the mass of full sphere? 2m. M and m, 2m. So 2x due to full hemisphere equals to g into total mass of the sphere by r square. So x is going to be gm by r square. But what is x? F cos alpha. X is f cos alpha. F cos alpha is gm by r square. And they said acceleration is 1 unit. So applied force is applied force equals to mass times of acceleration, right? So I can say like these two will be getting cancelled. From here you need to find what is gm by r square. That cos alpha is given in the question. Alpha is in 0.1 radian. So you can use that approximation of cos theta is almost 1 minus theta square by 2, where theta is in radians and theta is very small, right? A uniform sphere of radius 4 and density is divided into parts by plane at a distance b equals to 1. You are cutting this part, so you will be getting when you cut this, you will get this cross section as circle. Find the gravitational force of attraction between the two parts. So field is going to be different at different points, so we will be taking any one element, circular element, we will find the force on that element and we will be integrating it. So that's the idea. So instead of going with field and force, I am just going with pressure thing. You can go with field and force also, but I have already done this question in some of the doubt section. So where I calculated what is the pressure at a distance r. This is force, so I can find the pressure. Pressure is force by area. So that is gm by r cube into rho into r square minus r square by 2, where this capital R is the radius of the bigger thing, where this small r is at the point where I am finding it. So I am going to use pressure thing. So I need to find the force on this circular cross section. So I am going to take one ring of radius r and thickness dr. So if this radius is r and this thickness is dr, then this length, this corresponding length is going to be root of 1 square plus r square. So then by using pressure there, gm by total radius cube into rho into capital R square minus small r square, capital R square minus this distance square by 2. So that is the pressure at every point. Now pressure times of area is going to give me force. I know by symmetry the force has to be only in this direction, so I can go with pressure times of area. So pressure is this much, so pressure times of area of this element. Area of this element is 2 pi r dr. So that is the force on that element. Now we need to integrate it. Sorry, there is a mistake here. We need to integrate it from, I think integration limits were problem. So you can do by yourself. Integration limits r should be varying from 0 to this thing. 0 to root 15. I think I made mistake here. I think this is correct. So limits will be varying from r equals to 0 to root 15. So substitute 0 to root 15 probably. This was, I think I was not getting 0.2, I was getting approximately 0.2. Probably checked like limits 0 to root 15 or if there is any mistake. But you can go with pressure times of effective area, or you can go with integration of force on this element also. So you know what is the field here, you can multiply field into mass there and you can integrate it, right? So idea is fine. Find the gravitational force acting between a long half hollow cylinder of length L and radius is and its rectangular base, mass of half cylinder and rectangular base 1. See, again this question is similar to this question, so I will be discussing this question. You can do that question in the similar manner. So basically the question is, you need to find the force on the base due to the half cylinder. See, again essentially it boils down to the same idea of flux into charge density when it's symmetrical situation. Now if you take any strip, that is going to make an angle 90 degrees with the base. So 1/4 of this flux is going to go in this direction. So if I take any charge, 1/4 of the flux is going to go in this direction. 1/4 of the flux is going to go in that direction. So what is the total flux going through this plate? Total flux going through this plate is going to be 1/4 of q by epsilon naught. Flux going through the plate is going to be 1/4 of total flux because of this charge. Total flux because of this charge is q by epsilon naught. That's the only idea. You need to see, if you take any strip, 1/4 of the flux is going to pass through the base. So if you take any strip, 1/4 is going to pass. When you integrate it or like when you summate it, you will understand like out of the total flux, 1/4 will pass through this area. So flux passing through that area into charge density of the plate. Right. Now there was some extension question that you can take care by yourself. Again, in a gravity free space, there is a giant sphere of water of radius with a thin pipe passing through its center. If a small hole of 2 cm radius is made of that pipe nearly at the center of the giant sphere, take water to be of uniform density, find the velocity with which the water starts filling the vacuum pipe. See, basically they were expecting for us to use Bernoulli's, assuming there is steady flow. So you'll be using like energy conservation from here to here. P plus half rho v square plus rho g h here equals to P plus half rho v square plus rho g h here. Now here pressure I have already shown you some like old PDF like where pressure we got this much. Now this is almost at the center, so at the center small r is going to be 0. So pressure at the center we can calculate. So pressure here is going to be this much. So pressure here plus rho g h, I am taking this as my reference, so it is 0 plus half rho v square, which was 0 velocity. Now when it is going inside, this is vacuum, so pressure is 0 and rho g h term is 0. That pressure energy is going as kinetic energy thing we will be considering, right? So from here you need to get the velocity. P value you can substitute from there, and all the values you can substitute and you can get the answer, right? For that you should be knowing the pressure equation. A particle is projected from earth of mass m with velocity at an angle 60 with the vertical. Find the maximum height attained by the particle. So with the vertical you are throwing at an angle 60 degrees with this much velocity. So what is the energy at the surface? It is going to be potential energy plus kinetic energy. So total energy is going to be this much. So there is some good thing about elliptical path. Now you know when you are throwing at this angle, like it's not going to be like circular motion, it is going to be elliptical path, and total energy is negative, so it is going to be bounded path, so which is elliptical path, but of semi-major axis r or major axis 2r, because that derivation I am attaching here, which was there in again revision class. So when it is elliptical motion, total energy is going to be, minus gmm by 2a, that is 2a is 2 times of semi-major axis or major axis. Now from here we can conclude major axis is of the length 2r, major axis is of the length 2r. Now they have solved it in a slightly different way, I think you can look into that solution also. So basically this length plus this length in a ellipse is going to be major axis. So this length plus this length has to be 2r, but the good thing happening here is this length, now that should be a part of ellipse, and this length is already r. This length is already r, so this length also should be r. For that to happen, this point has to be this point. So this is r and this is r. This is r and this is r. So this particular point is going to be this point, and this one is focus. This is one focus. This particular point is this particular point, and this is focus. Now when you draw this thing to the other focus, that length also should be r. When you draw that length to the focus, that length also should be r. Now by geometry you can understand when you draw a circle of radius r, it will touch this point. So this is one focus, this is one focus. Now this angle is 60, so this angle is 60. If this is 60, then this angle will be 60, because similar sides, similar angles. Now this is 60, this is 60, then this one also will be 60, so this length is going to be r. Now if this length is r, I can easily show you this length is r by 2. I have drawn another figure here. So you are throwing like this at an angle 60 degrees with this. From here we concluded like anyway this length is r, this angle is 60, we concluded this is going to be another focus, this angle is 60, these two lengths are r, this length is r. Now major axis length has to be 2r, Now by symmetry I can say like this has to be r by 2, this has to be r by 2. So from the surface it will travel a distance of r by 2, maximum distance from the surface. So r by 2 is 3200 km, right? Next question, a small bead can slide without friction on a wooden rod of length. Initially the rod and the bead are held motionless along the rod, with rod aligned radially with the earth. The left end of the rod is at a distance r0 from the earth center, and the end of the bead is at a distance 2 cm away from the left end. Both bodies are released simultaneously, considering gravitational interaction only with the earth. If time taken after the release by the bead to separate from the rod is. A small bead can slide without friction on a wooden rod of length. Initially the rod and the bead both are held motionless. The left end of the rod is at a distance, okay. So basically they both will be having some acceleration, so you need to see like relative motion. I think this question, this question was similar to this question, and which already came in one of your exams. Where this was solution from that exam. So what we did here, we found the force acting on the rod by integrating, and we found acceleration of the rod. Then we found force acting on the bead. From there we found what is the acceleration of the bead. Then we found relative acceleration. Relative acceleration is going to be constant magnitude, so I can use S equals to ut plus half at square for relative motion. Relative distance traveled has to be x naught. From there I can calculate what is the time taken, right? This one was already from one of your exams, so you can manage. We integrated and we found the force on the rod such that we can equate it to mass times of acceleration to get what is the acceleration of the rod. Similarly, we found what is the acceleration of the bead and we took relative motion. This is the same thing. Whichever solution looks good for you, just look into that, right? Okay, going to the next question. Yes, this question was already taken in like your revision class. Yeah, I started from here. When there are three equal masses rotating about their center of mass, what is the angular velocity, what is the time period? Similarly, when there are three unequal masses, what is the angular velocity and what is the time period? This was already taken in revision class. You can look into that, or like you can pause and you can look at the solution. You can understand by yourself. But mathematically, it's like a slightly it's mathematical oriented because masses are unequal. When masses are unequal, we know like it has something to do with center of mass. So we'll be writing center of mass location thing first. So this thing has of some importance for us. We'll be writing the force on any one guy and we'll be manipulating the equation and we'll be seeing what is the time period, right? This is the same solution. Whichever looks good for you, just look into that, right? Okay, anyway, I'll upload the PDF. You can look into the PDF thing. So the next question goes like, to disperse all the mass of the earth to infinity against its own gravitational field, we need to give this much amount of energy. So that's like that much energy is needed to break the earth. So if earth is forming from infinity, like if all the particles are of earth were at infinity and they come closer and they form earth, they will be giving this much amount of energy. That's what they were saying. So while earth is forming, if you assume these are the initial conditions, when the particles are coming from infinity and they are forming the earth, they will be giving this much amount of energy. That much amount of energy, if it is going as heating earth, then what is the temperature change, right? So energy released is this much, that will go as increment in temperature, ms delta T. All the values were given in the question. You can directly substitute and you can get the answer, right? Thank you.